Okay, problem one. In the morning, the passenger train made the trip in 5 hours. In the afternoon, the freight train made the same trip in 8 hours. So we see the words made the same trip. So if I was to draw a picture to represent this, we have the passenger train going some distance. We don't know how far it goes, so we'll put d sub p to represent its distance. The afternoon, the freight train made the same trip, so we don't know how far it went, but we know it went the same distance. So our first relationship, our first thing we have to deal with is to deal with the relationship of distances. D sub p is equal to d sub f. Distances are equal to each other. Once we've established that, we go to our chart, rate time distance. Our categories will be the two trains, which are the passenger and the freight train. We know exactly how much time, so we're looking for rates and times. We're looking to fill in these four boxes. The passenger trip made the trip in 5 hours, and the freight train made the trip in 8 hours. The freight train speed is 30 miles per hour less than the passenger train. So if the passenger train is going some speed r, the freight train is going 30 miles per hour slower. And that means that 5 times r, we multiply rate times time to get distance, will be the distance of the passenger train. And r minus 30 times 8 is going to make 8r minus 240 for the distance of the freight train. We've already established they're equal to each other, so if I set these equal, I'm going to get 5r is equal to 8r minus 240. The 8r to the other side, that gets me negative 3r is equal to negative 240. We divide by negative 3, that gives me r is equal to 80. Going back to my chart, there's 4 boxes that we have letters in. That represents the 4 things we don't know. I want to see what I'm looking to find. It says find the rate of each. I want the rate of each train. So if I look at r is right here in the passenger train rate. So this is the rate of the passenger train of 80 miles per hour. And the rate of the freight train is r minus 30. So 80 minus 30 is going to be 50 miles per hour. That's all they asked us for, so that's it. The other thing they may have asked us for is how far did either train go. 80 times 5 is 400, 50 times 8 is 400, the 400 miles would have been the distance. So always answer the question they asked for. In this case, rate of each is what they asked for. Number 2, Vanessa rode her bike to the conclave at 12 kilometers per hour, then walked back to school at 3 kilometers per hour. The round trip took her 15 hours, so a round trip. So she she rode her bike, so she went some distance on her bike that we don't know, and then she walked back, and that's a situation of round trip, and that means the biking distance is equal to the walking distance. Once again, the distances are equal to each other. Priority 1 is to establish that. So we got bike and walk. So looking at, again, rates and times, trying to figure those things out. She rode her bike at 12 kilometers per hour, that's a speed. She walked back at 3 kilometers per hour, also a speed. And this says the round trip took her 15 hours. That doesn't mean it took her 15 hours to get there or 15 hours to get back, but 15 hours total for the whole trip. Anytime you get a total time, the way you handle that is one of the times is t, the other is going to be the total minus t. Has to be in that order. You do it in the wrong order, you're going to get the wrong answer. So, round trip took her, the total time was, anything like that. One's t, the other's total time minus t. Once again, rates and times are established. Rate times time equals distance, so 12t. Binomial times the number, so we have to distribute 45 minus 3t. The distances of biking and walking are equal, so we take those and set them equal to each other. 12t is equal to 45 minus 3t. 3t over change the sign, that gets me 15t is equal to 45. So t is equal to 3, and 3 is our biking times, that's 3 hours. The question this time says, how far was it to the side of the conclave? They want to know the distance there. That's the distance to the conclave, that's the distance back. It's the same distance, so basically what they're asking us for is that right there. So once we know what t is, t goes right there, so 12 times 3 is equal to 36 kilometers. And I know it's kilometers because it says kilometers per hour. Make sure we use the proper units on these answers. Number 3, ice cream bars cost 30 cents and whifferdils cost 50 cents. Gary and Cavender treated all the kids and they spent $21.50. How many kids had whifferdils if they numbered 5 less than those who had ice cream bars? So, some of the kids had ice cream bars, others had whifferdils. This is a number of kids, ice cream bars, and whifferdils. And the value of these treats, every ice cream bar cost 30 cents, and I kids had them, so 30 I, and we're doing value in cents. And every whifferdil cost 50 cents, and there were W of them, so 50W is the value of the whifferdils in cents. And they spent $21.50, which is the same as 2,150 cents. So make sure the unit of currency is the same. So if we look at fact number 1, they spent $21.50, better known as 2,150. That has to do with value. So 30I plus 50W is equal to 2,150. You don't have to do this, but since everything that ends in a 0, we can break that down to 3I plus 5W is equal to 215. The other fact is the whifferdil kids, that's the they, numbered 5 less than those who had ice cream. So the ones who had ice cream, there's more of them. So I is bigger than W by 5. So if I put I equals W, I know this is false. This is 5 less than that, so I have to do plus 5 to the smaller number to get the bigger number. I could also do I minus 5 equals W, take your pick, but that's how to handle that. So substitution set up here, I is equal to that, so this I can be replaced with W plus 5. So that gets me 3 times W plus 5 plus 5W is equal to 215. Replace one object with more than one object, use parentheses. Distributive property gets me 3W plus 15 plus 5W is equal to 215. Put the 15 over here, combine like terms, 8W is equal to 200. Divide by 8, we get W is equal to 25. And that's what they're asking for. How many kids had whifferdils? 25 kids had whifferdils. If they want to know how many had ice cream bars, 25 plus 5 is 30. They didn't ask for that though. Number 4, the tank contains 4 volleyballs and 11 soccer balls. The coach draws one ball at random and does not replace it. Then he randomly draws another ball. What is the probability that both are soccer balls? So very careful. It says does not replace it. That means once we pick the ball out that we're going to get what we were looking for and we're not going to put it back in. So we're looking for probability that we first pick is a soccer ball and our second pick is a soccer ball. So our first pick, based on the facts that we have, there's a total of 15 balls in the tank, of which 11 are soccer balls. We always assume we got what we're looking for. So the first pick, getting a soccer ball, there's a chance of getting one of 11 out of 15. Once we pick that, now there's one less soccer ball. So now there's only 10 soccer balls and still 4 volleyballs. So now there's only 14 balls, of which 10 are soccer balls for our second probability. And then we simply reduce and multiply, if possible, reducing. So 10 and 14 reduced by 2. 5 and 15 reduced by 5. Nothing else reduces. 11 times 1 on top makes 11. 3 times 7 on the bottom makes 21. So 11 out of 21 is the probability that we get 2 soccer balls in that scenario. Number 5, graph the solution of this. Job 1 is to solve the inequality. Move the 2 to the other side. That gets me negative 3x is greater than or equal to 6. Moving things across an equal sign like that, changing the sign does not change the inequality direction. The next step, the division step, is where the direction might change. I'm going to divide by negative 3 on both sides. That becomes positive, this becomes negative. Signs change because of division by negative, so we flip the inequality around. Equal stays equal though. So greater than becomes less than, equal stays equal. Our domain's a set of real numbers. We want to graph everything less than or equal to negative 2. So maybe negative 4, negative 3, negative 2, negative 1, 0, 1, 2. less than or equal to means that we're going to put a closed filled-in circle. Less than goes to the left, and again, real numbers, we're going to be shading the line. Had that said integers, we would have gone dot, 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 and shade the arrow, but reals include all the fractions and decimals, so we go ahead and bold in that line. Number 6, solving a quadratic equation. Job 1 is to get everything equals 0, so I'm going to move the 11x and the 30 over. We want x squared positive, so x squared is fine where it's at. 11x becomes positive, 30 becomes positive, both moving to the left. Then we're looking for our two numbers that multiply to make 30, that also add to make 11. Positive 5 and 6 do the trick, which means that our factored form here is going to be x plus 5 times x plus 6 equals 0. Once we get to this point, we use the zero product property, which states once we get a product equal to 0, either factor 1 is equal to 0, or factor 2 is equal to 0. And then we solve each of these individually, move the 5 over and subtract, so x equals negative 5. Move the 6 over and subtract, x equals negative 6. There's our two answers. And when it says solve, we're looking for answers like that. If you give me factored form, that's not right. You have to get all the way down to x equals these two numbers. Number 7, this is a binomial quadratic. We have an x squared and a constant. There's no x term. If I'm going to do it by factoring, I'm going to move the 25 over here. I'd like my x squared again positive. So 9x squared minus 25 on the right equals 0. With a binomial, we're looking for a difference of squares. 3 times 3x times x, 5 times 5, opposite signs. One positive, one negative. So when we get that, the factored form is simply square roots. 9x squared in front, square root 3x, 3x. 25 in back, square root 5 and 5. 25 is negative, so one positive, one negative. At this point, we have factored form equal to 0, so same deal as before. Zero product property. Either factor 1 equals 0, or factor 2 equals 0. And these are two-step problems because of the number in front of x, but job 1 is move the 5 to the other side. That gives me 3x equals negative 5. Divide by 3, I get x equals negative 5/3. Move the 5 over here, change the sign. 3x equals positive 5. Divide by 3, we get x equals positive 5/3. Number 8, this is very much like number 6, a quadratic trinomial. Job 1, move everything to the other side. This is positive x squared, so let's find where it's at. 15 moves over, becomes positive 15x. 44 becomes positive 44 equals 0. Again, we're looking for those two numbers that multiply to make 44, add to make 15. 4 and 11 are those two numbers. If you can't figure out those two numbers off the top of your head, factors of 44 whose sum is 15. 1 times 44, 2 times 22, 3 doesn't go into it, 4 times 11, 5 doesn't go into it, 6 doesn't go into it, 7 doesn't, 8, 9, 10 don't, 11 does, and we already got that one. So there's every pair of numbers possible, 45, 24, 15. 1 plus 44, 2 plus 22, 4 plus 11. So if you can figure it out off the top of your head like that, fine. If you can't, just systematically go through all the possible ways of doing it, and you'll find the right pair. So that gets me a factored form of x plus 4 times x plus 11 equals 0. And just like the last two problems, factored form equals 0. So either factor 1 equals 0 or factor 2 equals 0. And solving each one individually, move the 4 over, change the sign, gets me x equals negative 4. Move the 11 over, subtract, we get x equals negative 11. Number 9, division of polynomials. We're dividing this polynomial by that. X squared and x to the first are both missing from this. So the divisor, what we're dividing by, goes outside. Might help to use the right one. X minus 2. What we're dividing into goes inside, x cubed. And I'm going to put a plus 0x squared and plus 0x to account for the missing powers of x, and then minus 7. So x cubed minus 7. These are just there for spacing. They don't add or subtract anything to the problem. They're not going to create any kind of new answer. They're just there to create space. The division process is what it has been. We divide first by first every time to get an answer. So x cubed divided by x makes x squared. answer times divisor to get product. So x squared times x makes x cubed. X squared times negative 2 is negative 2x squared. We subtract by changing signs. So this becomes negative, that becomes positive. X cubed minus x cubed cancels. 0 plus 2x squared makes 2x squared. And then just bring everything else down. Plus 0x minus 7. Again, that 0x squared didn't do anything. That's positive 2x squared, that's positive 2x squared. It just gave me a spot to put the x squared term because it showed up. Next division. Positive 2x squared divided by positive x makes positive 2x. We multiply answer times divisor. 2x times x makes 2x squared. 2x times negative 2 makes negative 4x. We subtract, and subtraction is changing signs. This becomes negative, this becomes positive. Positive 2x squared minus 2x squared cancels. 0 plus 4 makes 4x. And then we bring everything else down. Once again, we divide. First divided by first. As long as there's x's down here, we've got to keep dividing. Positive 4x divided by x is positive 4. 4 times x is 4x. 4 times negative 2 is negative 8. Next job is subtraction. Subtraction is changing signs. 4x becomes negative, 8 becomes positive. Positive 4x minus 4x cancels. Negative 7 plus 8 makes positive 1. Since that's a positive 1, I'm going to put a plus sign for the positive. And then I put the remainder 1 over x minus 2, the divisor. And that will be my entire answer. Number 10, simplify. First thing, I notice there's a bunch of zeros here. Every pair of zeros gets to be a 10. So I've got 2 pairs of zeros here. So altogether this is 400 times the square root of 18. That's the first thing I would do before I did anything else. So 1 pair of zeros got me this 0. The second pair of zeros got me this 0. If there was an extra 0, that would stick on this, but there's not. So 2 pairs, 18 still there. Everything else I'm just going to bring down as is. So this is plus 400. And this is 2 times the square root of 8 minus 3 times the square root of 50. That's the first thing I would do. I would just, again, leave all this stuff alone and just fix that piece right there. The next thing I'm going to do is each individual thing I'm going to break apart as much as possible. So 2 is fine the way it is. 8 is 2 times 2 times 2. If that's something you can do mentally, fine. If not, do a factor tree over here. 8 is 4 times 2. And 2 times 2 times 2 is what ends up happening. Again, if they're small enough, you can just figure them out in your head. That's fine. I don't mind that at all. The second one, minus 3 times the square root of 50. I'm going to do this. I'm going to put minus. I'm going to leave a little space here just for the fact that I'm going to be pulling stuff out. I want to have some room there to do it. 50 is 2 times 5 times 5. Same deal for the factor tree. If you can mentally see 50, that's fine. If not, factor tree it somewhere. And then this last one I've got plus, and again I'm going to leave myself a little space here, 400 times the square root of 18. 18 is 2 times 3 times 3. Okay, so that's, once you've gotten this broken down with the zeros, then you want to break down each of these numbers to prime factors. And then we're looking for pairs inside in order to pull one thing outside. So I got a pair of 2's inside, I can pull 1, 2 outside. This 2 doesn't have a pair, it has to stay in. I have a pair of 5's inside, I can pull 1, 5 outside. The other 2 has to stay in. And I've got a pair of 3's inside, I can pull 1, 3 outside, the 2 has to stay in. So altogether, what ends up happening for the black one here is going to be 4 times the square root of 2. 2 times 2 is 4, the square root of 2 stayed in. For the red one, minus 15 times the square root of 2. 3 times 5 is 15 outside, it just being subtracted, the square root of 2 stayed inside. For the purple one, 3 times 400 is 1200. Inside is the square root of 2. At this point, it's addition and subtraction of radical expressions. They have to have the same radical in order to add or subtract. Square root of 2, square root of 2, square root of 2, so we are allowed. So 4 plus 1200 is 1204 minus 15 is 1189. So 1189 times the square root of 2. If they can add and subtract, you add and subtract the coefficient. The square root of 2 just comes along to the right. Number 11, solving a system of equations. This setup here with x then y equals number for both lends itself better to elimination than substitution. So I would take the top equation times 3, seeing that if this becomes positive 3y to match with that negative 3y, elimination will happen. So 3 times 3x is 9x. 3 times y is plus 3y. 3 times 15 is 45. If I now add these two equations together, 2x plus 9x makes 11x. Negative and positive 3y cancel. Negative 1 plus 45 is 44. By eliminating y, we're only left with x. If 11x equals 44, we divide by 11. That gets me x equals 4. We're looking for an ordered pair, 4 comma something now. X goes first, y goes second. We found x. Wants to know what x equals. I go back to one of the two equations up top. The top one says 3x plus y is equal to 15. But instead of x, I'm going to write 4 because that's what x equals. 3 times 4 is 12. And if I move the 12 to the other side, I get y is equal to 3. Solving a system of equations, we're looking for an ordered pair answer every time. Number 12, simplify. Our top number here, we want to change that to good scientific notation. 1, 2, 3, 4, 5, 6, 7 spaces, get the decimal point there, so 8. If you want to put 0.0, you can, times 10. And I again moved it 1, 2, 3, 4, 5, 6, 7 spaces, making it bigger by 7 decimal places. I have to make this smaller by 7. Negative 20 minus 7 is negative 27. On the bottom, I've got this. Decimal points here, I want to put it right there. So 2 times 10. And 1, 2, 3, 4 spaces smaller, so I have to make this 4 bigger. Negative 8 plus 4 is negative 4. That's being multiplied by this, which decimal points there, I want to put it right there, so that's going to be 2 times 10. 1, 2 spaces smaller, so I have to make this 2 bigger. 7 plus 2 is 9. So, priority 1, get everything in good scientific notation. Next step, the top is fine the way it is. It's just a single scientific notation number, 8 times 10 to the negative 27th power. The bottom, I want to multiply those two things together. So if I want to multiply these, abscissa times abscissa gets me new abscissa. So 2 times 2 makes 4. And then powers of 10, I'm going to add those because 10 to a power times 10 to a power requires me to add the 2 powers. Negative 4 plus 9, adding algebraically, ends up being positive 5. Once you get to a single scientific notation over a single scientific notation, the division is divide the front numbers. 8 divided by 4 makes 2. And subtract the powers of 10. And this is something I recommend actually writing down. Top power of 10, bottom power of 10. Top power of 10 minus bottom power of 10. Actually write it down on your paper so you can look and see what it looks like. These signs are the same, so even though the rule says subtract, subtracting with a negative involved ends up creating an addition of the two objects. So negative 32 is what we're going to get out of that. Most common mistake here, people get to this point, they think subtraction, they say 22 instead of 32 because they don't actually look at it. So top minus bottom, look at the signs in order to add or subtract. Signs are the same, you add them together. Number 13, solving a fractional equation. Least common denominator 35, 7, and 5 is 35. So I'm going to multiply by 35. Divide, then multiply. So 35 divided by 5 is 7 times x is 7x. 35 divided by 5 is 7. That minus sign is, 35 divided by 7 is 5. That minus sign is attached to it. That's going to multiply by 4 plus x to the top. The top is a binomial, and that quotient of 5, which is actually negative 5, is going to distribute through that whole top. So negative 5 times 4 and negative 5 times x. Be careful of that. 35 divided by 35 is 1 times negative 4 is negative 4. So fractions are legally eliminated. Again, as long as there's an equal sign, multiplication by a common denominator, that's a legal step. Then distributive property finishes simplifying, so I get minus 20 minus 5x equals minus 4. I'm going to move the 20 over here. Negative becomes positive when you move across. 7x minus 5x is 2x. Negative 4 plus 20 is 16. We divide by 2, we get x equals 8. Number 14, surface area of a sphere. The surface area formula for a sphere is 4 pi r squared. The radius is 3 inches, that's r, so it's going to be 4 pi times 9. I recommend squaring it in your head if it's easy enough to do so. If you want to write 3 squared, you can. Just make sure you square 3 first before you multiply the 4 pi. So we multiply that, 4 times 9 is 36 pi inches squared. I'm perfectly fine with that answer. If you want to approximate pi with 3.14, 113.04 inches squared is also the correct answer. Take your pick. I'll take either answer. Number 15, lateral surface area. Now the surface area of a prism is 2b plus pH. Lateral surface area, they want the area of the sides, not the bases. So the area of the bases is right here, so we throw that out. So the lateral surface area is just pH. Now it tells me the bases are regular pentagons. Regular pentagon simply means all the sides are the same measure. So if that's 10, then this is 10, and this is 10, and this is 10, and this is 10. So there's no confusion. 10 is that slanty side there. So the base is a pentagon, every side measuring 10, 10, 20, 30, 40, 50. So the perimeter of the base is 50. The height of the prism is 12. And lateral surface area is simply the product of these two numbers. So 50 times 12, which is 600 feet squared. On the test, it will be a regular base. It may be a pentagon, maybe it's a hexagon or a quadrilateral, whatever, but the base will have all the same dimensions, so you just have to count up how many sides there are to find out what the perimeter is. Multiply whatever that perimeter is times the height, you get the lateral surface area. It'll be just that easy.